A little bit tough to decide what to work on today. Most of these things are mostly done. Well, most of them. I put more time in on that. Just got good storyboards, but that's a serious and slightly depressing topic. Probably save that for the weekend when I have more energy. Sometimes my day job really drains me. By the end of the day, I don't want to deal with serious and depressing topics. And I think that's okay. I think that's a normal thing. Everything. People only have so much mental and emotional energy. Once it's spent, you need to take some time to recover. And I know some people will think that I'm weird for finding math and writing about math relaxing. But I do. Much easier than dealing with people who disagree with each other. Especially since the people at my job disagree with each other because they're not actually like talking to each other. If they're talking, they haven't bothered to make sure that the words that they're using them the same. Which is a problem in math, I'll admit. That does happen sometimes. That's why I try to include the technical terms in these slides, even when it's not really the focus. Try to explain things with images as much as possible. I do want to include the words. If a viewer runs into them again sometime in the future, a little bit of connection in their brain. Let them recognize the word a little bit. Seems like my microphone's picking up a little bit of background noise today. Probably inevitable. Still not having pleasant weather here. Large section of the United States has been having high heat conditions for more than a month now. Something like that. It'll be annoying. Nothing we can do about it, though, really. Maybe I'll think about something more lighthearted. And it's scripts for order of operations. I don't hate that one as much as I hate foil. My big issue with PEMDAS is that it doesn't really promote any understanding. It's just kind of a here, memorize this. Right? And a lot of people run into trouble with this one because it leaves out that multiplication and division are the same. So are addition and subtraction. So people get really caught up in, do I do addition first and then subtraction? I have to go left to right? You don't have to go left to right, by the way. It doesn't matter whether you do addition or subtraction first. You just have to make sure that any numeral that has a multiplication or a division on one side and an addition or a subtraction on the other side, you do the multiplication division first. I really do mostly recommend that people, if they're having trouble with it, convert all of their divisions into multiplications right away. Not sure why. People don't seem to have quite as much trouble with equivalence between addition and subtraction. Maybe something about negative numbers is inherently easier to understand than fractions. So, unrelated, I didn't spend enough time blending the fruit for my afternoon smoothie, so I have big chunks of watermelon. It's not a big problem. As far as problems go, I'd say that's actually a fairly small problem. Efficiency versus mastery thing. Yeah, it's another relatively serious topic. I do wish there was something more that we could do about it, though. There's, honestly, unless a child's parents are willing to help out, there's not a lot of resources, I think. Well, that's half true. If a child understands what they're struggling with, then the internet has plenty of resources. Unfortunately, that's usually the problem, is that a young, like, first through fourth-ish grade student, when they're struggling with a subject, they don't know why they're struggling with the subject. They just know that it's hard. Right? They don't, you know, may have an intuitive understanding that they've missed something, but they couldn't, generally speaking, point out what it is that they've missed. They also have a tendency to just guess when they don't know. I've run into that a lot. Sometimes I run into that with college students that I'm interviewing at work. 20 somethings that want to do an internship. I'll ask them an interview question and ask them to solve a problem, and they'll write down the answer, or whatever they think is the answer, and then they'll turn around and they'll ask me, "Is that right?" It's always a little exasperating because that's half the point of interviewing somebody. I'm a software engineer, so I'm interviewing people for software engineering positions, right? It's one of the big parts of being a software engineer is learning how to check your work. Right? If we hire you for real, you're gonna do your work, you're gonna write your code, then it's gonna run. And if you didn't test it thoroughly beforehand, you're gonna break something. Which happens all the time, but breaking stuff is totally normal in the software world. There's a reason that there's beta releases, for instance. Always try to roll out released to testing environments and early adopters, people who don't mind their software being broken a little bit. Always roll it out to them first. So, an interesting thing, a culture that we've developed where people who use software, sometimes even paying customers, are willing to be on an early release track. They get new features first, but in exchange they also get broken features first. I think it's interesting how many people are willing to do that, to make that trade. And it also comes with the responsibility that when something is broken, you have to write a report so that it gets fixed. I mean, I guess there's just a certain portion of the population who finds that interesting, or maybe they are just that into being the first to get new things. Definitely a couple of my friends are like that. I have a friend who always, for every product that he uses, except for the ones that he absolutely needs for work, but everything else from video games to telephones to apps and applications and everything has to be the newest. He loves having the newest thing, the newest features. And he's willing to deal with bugs in order to get it. He's also a software engineer and he writes reasonably good bug reports. So I guess all of the programs and projects that he's an early adopter of can be thankful for him and people like him. I'm I'm mostly not that sort of person. I like the stable release track. Right? I For most products, I don't use advanced features. Right? A lot of the things you use, you don't really need advanced features or new features. Like my GPS application. I tried putting that on the beta track for a while, but I found the inconvenience of it not working was totally not a good trade-off compared against the occasional new feature. Like, some people like it, but I'm more focused on getting where I'm going and not needing to stop and figure out what's wrong with the application. Yeah. Even when somebody does convince me to get onto an early track, I usually keep a backup of the stable release. So if there's a bug and I am in a hurry, I don't have time to figure out what's wrong, I can just turn the experimental features off. But these days, I think I've opted out of just about everything. If you're the sort of person that's always waiting for the newest release of your favorite software, consider signing up. I want to do experimental today either. Maybe order of operations. I have. Whether or not you can prove you exist, I'm not going there today. That's a deep topic. Many people find it very disconcerting. So why does Chrome need an extension to access clipboard? Right? Especially since I can copy things to the clipboard. Over here, I just hit copy link, and it copied the link. Then I go over here. I can't use the mouse or the edit menu, but I can use the keyboard. It's very curious. And of course, this is kind of a false distinction. So everything that I'm labeling a math bite is probably going to tend to be a false distinction. So they're just there to get people emotionally involved so that they think about the topic. Because the catch is in arithmetic and basic algebra, you can't put the equal sign inside of the parentheses. That's not valid. Like, open parenthesis, x equals y, close parenthesis, doesn't have any meaning in arithmetic or algebra. Or any of the algebra-based disciplines for that matter. Geometry, trig, calculus. Right. Extending anywhere in that direction doesn't do anything. Where it is valid is in logic. If you're writing out logical expressions, then x equals y is not necessarily a statement. It could also be a question. Right? So using the same symbols to mean something slightly different means, does x equals y? But we've seen that trolling people with questions like this that are kind of a wrongly asked question seems to get a lot of engagement. Here on this one, there are it's really 3 different positions. keyboard with a slightly bigger than the A button so that I stop hitting caps lock all the time. Leave it to your imagination whether the issue is that I have a small keyboard or whether I have giant hands. The third option is that I could just be a little bit clumsy when I'm typing, and my pinky goes a little wild and likes hitting that caps lock button. So what we teach in school is attempt to distill the most useful systems of mathematics for students. The truth of the matter is it usually is nice to have consecutive numbers always be the same distance apart. That's not strictly speaking a requirement. Most number systems do it that way. And they do it that way because you need to have some pattern for defining your numbers if you want your set of numbers to be infinite. There are number systems that have set number of numbers, right? Like what we call the modulo systems. For instance, the ones that your clock uses is modulo 12. Your clock only has 12 numbers. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Most clocks don't actually start from 0. They start from 12. Right? So 12 and 0 are kind of the same in the system. For those of you that use 24-hour clocks, same idea, just more numbers. Yes. The point is that you can make a number system that's cyclical. It doesn't have to have infinite numbers. Although in the case of clocks, that number system, the numbers are the same distance apart. They just are wrapped around in a circle, so you end up back at the beginning. It's just really convenient when the numbers are the same distance apart. Right? Most arithmetic operations work way better when your numbers are evenly spaced. It's not required. If you really wanted to, you can build a system that doesn't have that property, that defines its numbers in some other way. You're gonna start to run into trouble when you want to define some operations to use on your numbers, like say addition. Right? One of the nice things about having evenly spaced numbers on your number line is that addition and subtraction really just flow naturally. Right? If you do something really scrambled, you're gonna have to mess with your definitions of your operations to make them come out the same. Generally speaking, when we have addition, right, we want it to be commutative so that we can swap the order of the numbers and get the same answer. We want it to be associative, so you don't have to worry about the order of operations too much. But there are definitely systems that don't have those properties. It's much more common to have systems where order matters for multiplication. That's pretty common. Frequently, systems that are trying to represent multiple dimensions will start to lose their properties on multiplication first. And you'll notice that when we generalize to exponentiation, even in the standard natural numbers, the order of exponentiation matters, right? It matters whether you do 2 to the 5th or 5 to the 2nd. Different answers. So, yeah, as you make your systems more and more complex, particularly when you're adding dimensions, you tend to lose properties working down. So you'll lose the properties of multiplication first, and then you'll lose the properties of addition after that. I kind of don't know what happens if you go and you generate an extra set of dimensions on top of that. What's all of the properties of addition of that? I'm sure somebody's done it. There's actually a relatively simple algorithm for generating new systems of numbers in that way. It follows the same pattern as going from. Usually we're going to start from either the integers or the real numbers. Maybe the rationals or the real numbers, but if we go from single dimensional scalar numbers up to including imaginary numbers, and generally we consider imaginary numbers to just be moving in a different direction than the real number line. Then you get complex numbers. So you have the real component plus the imaginary component. You can double that again to get the quaternions. So then you have the real component plus 3 completely different non-real components. I don't know if we want to call them imaginary anymore, because the first one is the imaginary numbers. After that, we really just start using letters. So imaginary numbers are the I component, and then quaternions have the J and K components. You can double that again to get the octonions, which is the 8-dimensional numbers. You can just keep doubling it. There's, so far as I know, there's nothing that actually stops you from doubling the system again and again and again. Other than that, we have found no practical use even for the 8-dimensional numbers, so at least not that I know of. I'm sure some researcher somewhere is using them, and they're important for their research. But I haven't seen any of those results creep into daily life. I haven't been looking particularly hard. They may be there, and I just haven't noticed them. But so far as I know, nobody's even seriously studying the 16 or 32 dimensional number sets. They're hard to work with. because when every number has 16 dimensions, it's hard to keep track. And B, we haven't really found a use for them yet. Now, there are a couple of people that are studying the concept in general, right? They're studying what happens as you keep generating more and more number sets in this pattern. I've got to be honest, I've never actually read their work to see what they've found. Might be interesting. Might go look that up sometime. What we have noticed is that sometimes there are ideas that are difficult to express if you don't have enough dimensions. So one of the areas of interest that requires more than one dimension is anything that requires waveforms. So optics, the study of light, or a handful of things that we do with electricity. Alternating current is a repeating sine wave. So it has phase relationships, right? And phase relationships are often described using imaginary numbers, right? It gives us a second dimension. And we sometimes see that relationships that are confusing on the real number line because they look like they have holes in them. That's the main reason. They are cyclical in some way that is not defined on the real number line. sometimes we find that if we define the same function in more dimensions, it actually is continuous function. It's just moving in a direction that doesn't intersect the real number line at all points. So you'll see that the function actually moves off into an imaginary dimension, and sometimes it'll loop back in a way that is, I want to say, more predictable, but maybe it's more accurate to say that the predictability is more intuitive if you can actually look at it in multiple dimensions. I mean, that of course brings up the other reason that nobody works in more than 4 dimensions, is because we can't picture 4 spatial dimensions. So trying to picture 8 spatial dimensions doesn't work. Like, the human brain is just not built for that. We can't imagine it in any sort of realistic or productive way. So really, you end up working with purely numerical representations, right? You can't have nice pictures in 8 dimensions because nobody can look at them. Also, since we only discovered 3 physical dimensions, you can't print out an 8-dimensional drawing. It doesn't work. It might be interesting to see higher dimensional objects intersecting with the 3 spatial dimensions, but so far we don't really have any evidence that such a thing even exists. Current theory is there might be as many as 13 or 15 spatial dimensions, but most of them are not and will probably never be visible to a human. It seems like most of the time they're either too tightly wound, like they're kind of rolled up and pointing in a direction that isn't real from our point of view, or they just don't have enough energy. So they barely exist, so we don't notice them, kind of in the same way that we don't notice individual air molecules, right? They simply don't have enough energy for us to notice them. Which may eventually lead to some macrophysical multidimensional research. I don't see that happening anytime soon, but like the same idea kind of applies, right? If we could group them together in a way where, as a whole, they have enough energy to interface with the macrophysical world, like the things that we can actually see. Theoretically possible. I think based on current research, it's not likely, and almost certainly not going to happen anytime soon. But weird things have happened. We're starting to be able to get quantum physics effects that are just on the edge of something that a human could theoretically see with their eyes. Which, practically speaking, means, no, it's still way too small. You can find physicists say things like, well, theoretically under optimal conditions. And of course, that ignores the fact that bouncing light off of something to view it directly tends to collapse most quantum systems pretty thoroughly. But it is exciting. We're getting larger and larger objects to demonstrate quantum properties. Although the largest is still vanishingly small. That's another thing physicists do. They say, we've made it so much larger. It's like, but it's still so small that it's invisible. Right, but it could, you know, that could be that could be trillions of times larger. Like, how big is a proton again? 10 to the minus 24 meters, something like that. Yeah, so if you made it trillion times larger, then it would be a meter. That might not be the size of a proton, but that's the sort of thing we're talking about. A human can comfortably see something that's about a millimeter. If we're being honest. Got really good eyesight, magnifying glass or microscope. You can see things that are small. Yeah, 10 to the minus 12, a trillionth of a meter. If you can even imagine chopping up a millimeter a million times, billion times. Yeah, chop a millimeter up into a billion pieces, and then try to imagine how small that would be. That's 10 to the minus 12. Most people, they just can't envision that. It's not something the human brain is designed to do. Which is part of the reason why so much of particle physics and quantum physics seems so made up. The results simply wouldn't make any sense on a scale that a human is designed to think about. So they end up being the realm almost of pure mathematics. Excuse me, pure mathematics. Which honestly is my recommendation if you ever take a quantum physics class. A lot of students start out by trying to find analogies between how quantum physics works and how macro physics, like real world life sized physics, works. And in some of these cases, there really isn't a good analogy. So trying to learn by comparison just doesn't work. My recommendation is skip the analogies chapter. Go to the chapter with all of the equations in it. Learn the equations. Learn how the math works first, right? Because at least the math you can understand. You might not understand how it applies to the real world, but you could learn how the math works, how all of the different pieces and parts relate to each other. And then go back and look at the analogies chapter. Right? Because then you have all of the concepts for both sides of the analogy in your head already, and you're just trying to connect them, which is much more straightforward than trying to develop the mathematical intuition through analogy. That doesn't really work. Mainly because the analogies are not very good. Maybe I should do a series on quantum physics someday. I think I think the main issue that most people have is they can't let go of their intuition that objects are solid. And below a certain scale and size, nothing is solid. In many ways, the most fundamental particles aren't really particles the way we imagine them. I suspect most of us imagine subatomic particles kind of like dust, or maybe like mini solar systems with electrons orbiting around them. That's not really correct. They do have some properties that make them kind of act as if they were solid objects, but mostly not. Mostly, once you get below a certain point, you start considering things more as their waveforms. And that's what we're always talking about, how light is neither a particle nor a wave. It has properties of both. Yeah, but at some point it makes more sense to stop trying to think about elementary particles as real world solid things and start thinking about them as collections of properties that happen to be grouped together in a physical space. I don't know if that's super clear though. Yeah, that can be the tricky thing about really any kind of research, is intuition can be useful. Intuition can help you make jumps and tell you where you need to look for answers. But you can't hold on to your intuition too tightly, because sometimes the results are going to come back and it's going to say your intuition is wrong, and you have to be willing to let that go, which is very difficult for most people. It has to be difficult on some level if you were willing to change everything about your worldview all the time. Then the world would have no consistency. Right? If I said, hey, the sky is red, and you suddenly believed that the sky is red, and then you went outside and the sky was blue, and then you suddenly believed that the sky was blue, and then somebody said, hey, the sky is green, then you believed what that person said. You would not be able to predict things. Right? That's the whole point of our intuition, is taking all of the experiences that our brain has stored, often not stored very well, but has stored in some fashion or another, and kind of trimming it down to the pieces that are important for predicting future events, mostly the very near future. Humans are good at predicting what's going to happen in the next 5 or 10 seconds. Right? You see people playing sports, right? Take baseball. The pitcher knows that if he or she makes certain movements, the ball will move in a corresponding fashion. The batter is watching the pitcher, make those movements and trying to predict what the ball is going to do. And then taking the prediction of what the ball is going to do and combining that with the prediction of if I move the bat in such and such a manner, then I'll get the outcome that I want, which is hitting the ball and hitting it in such a way that you don't get an out. You know, generally, I guess in baseball you want to make it on base, unless you're sacrificing yourself to let somebody else make a run. I think that's the thing with baseball players too. I haven't really watched baseball in quite a while. Used to sometimes go watch baseball, minor league games with my family as a kid. Don't really watch baseball anymore. Right, but the flip side is if the pitcher and the batter were trying to actually sit there and calculate out how all of the different motions were going to affect the outcome, A, the game would take forever. And B, it wouldn't work very well. Because the line where microphysics and macrophysics meet is kind of unpredictable, right? So the basics of kinematic motion, right? If you just kind of lob the ball into the air and it's moving without rotation through still air in a nice parabolic arc, that's predictable. Once you start factoring in fluid dynamics, so things involving the ball spinning and any wind, I mean, even down to things like temperature can have effects. In baseball, one of the things is the structure of the ball. Parts of it are smooth and parts of it are not. Can affect how the air and the ball move past each other. Right, once you start to slide into those fluid dynamics sort of realms, right, it's still looking at bulk properties for the most part. You're not trying to calculate every individual air molecule. But the more detail you look at it in, the harder it gets. Part of that's just because there's too much information. So that's where intuition comes in. Intuition says, I've taken similar actions many times before, and even if this is not exactly like any of them, I can take the results from those past actions and I can predict the approximate results based on current conditions. Right? So the pitcher knows, if they place their fingers in a certain way and move their arm and their legs in a certain way, they'll get about the same result every time. The batter doesn't have time to calculate the fine details. Once the ball is moving, they have a very short window of time. But they can make some broad judgments based on things that the pitcher has done in the past. Tells you things that the pitcher is likely to have done this time. You can get some information based on the pitcher's posture. Right? But at the end, they're doing the intuition thing again. Right? They're feeding all of that into part of the brain that has kind of condensed all of their past experience into a general plan of action, so that when conditions that make sense get fed into that part of the brain, it very quickly spits out an answer that is more or less correct. But that's why in research you have to be careful about trusting your intuition too much, because oftentimes in research, the thing you're trying to find out is something you don't have that much experience in, you might have experience in related topics, but if you really knew the answer to your research project, you would probably have picked a different research topic. It's rare for us to pursue projects that have been done many times before. It's usually valuable to do it more than once. If you only do it once, there's a lot of room for error to creep in. So it's usually good to do any given piece of research a handful of times. How many times? Depends. I think I've mentioned that before. Is anything involving humans, you need to do many times with many participants, because humans are not predictable and they do not stick to the research plan. And there are many things that you can't try directly. Many things you can't do because they would harm the participants. And generally speaking, our research ethics boards these days, along with the researchers and the general populace, will not accept a lot of harm done to the the study participants. There's always some level of harm. That's true for absolutely everything. So, as a for instance, when trying out a new medication, somebody has to be the first person to try it. Generally speaking, we've done everything we can at that point to make sure that it is safe, up to and including animal trials. And I know a lot of people argue about whether that's ethical. It's a question that doesn't have a right answer. That's a lot of where arguments come up with this sort of question. Is anytime you have two or more participants in a conversation or a debate or an argument who believe that they have a correct answer for a question that does not have a correct answer, right, you're going to get highly emotional confrontations as each side tries to press for their position, even if their positions are not actually that far apart on the total scale of possible positions. There are simply a lot of topics out there that we need to accept. There's no such thing as a correct answer. And we have to accept that in most of those cases, it's a balancing act between competing interests, neither side of which is necessarily inherently bad. But if we have conflict between different positions, then everybody has to find a balance between the two that they're comfortable with. And it's unlikely that the balance that you're willing to accept of whatever good versus harm we happen to be talking about, I'm sure you can think of a few things, but your balance is not going to perfectly match anybody else's. Even people who agree very closely with you are going to have slightly different perspective because they're not you. I'm not you, you're not me. Even on things that we agree about, broadly agree. We may have slight differences in the details. And that's fine. That's normal. That's how the world works. Ethics is not a solvable problem. You cannot say this given thing is 100% right all the time, and the opposite is 100% wrong all the time. That's not how ethics works. The catch is that we do still want we still want these disagreements to be productive. Often, if we're willing to calm down and discuss our vocabulary, that's something you see a lot in politics. Is you'll have a debate, with a couple of talking heads in it, and they won't really be talking about the same thing. They may be using the same words sometimes, but they haven't really agreed on the meanings of those words. So they're both setting themselves up where they can claim that they're right, because that's a lot of what politics is, right? Is convincing people that you're correct. And taking the time to define your terminology carefully and set out what your actual goals are and what metrics you're going to use to determine whether or not you're making progress on your goals is really boring. I find that a lot at work. When I end up getting stuck in the middle of a heated debate between other people who, for the most part, are on the same team. They want the same things. Sometimes it's just that they haven't taken the time to actually clarify what they're talking about. So they're talking about slightly different things, and that's why they can't agree. I've had more than one heated argument just collapse when I intervened and started defining terms and laying out goals and metrics, and the two parties realized that they actually wanted the same thing, and they both thought that the other person was arguing with them and wanted something different, but they actually wanted the same thing the whole time. And I want to be clear, my colleagues are very smart people. So this is something that can happen to anyone. And stopping in the middle of an argument and going, wait, are we sure that we're arguing about the actual merits and not arguing about a miscommunication? It's like stopping in the middle, when, especially once you get to the point where you're angry, that's very unnatural. That's something you need to actively practice. And honestly, it's often not enough to be willing to do that, because arguing is a two-player game. Even if you've realized that there's a miscommunication going on, I've sometimes found that there are people who are not willing to end the argument. I've definitely had people say to me in a discussion, "Oh, you've got that backwards. That's not correct. You've mixed it up." And I think about it for a moment and I go, "You know what? You're right. I did have that backwards. I did mix it up. Thanks for pointing that out." And then they continue to tell me how I've got it mixed up and backwards for another 5 or 10 minutes. And I'm like, yeah, I thought about it after you pointed it out the first time. I agree. You are correct. And then they continue to tell me how wrong I am. After a while, I just stopped talking because they're obviously not listening to me. Like they've gotten into argument mode. and they're not willing to stop arguing, even if I'm willing to concede that their point is correct, that I made a mistake. Try not to be that person, okay? If the other person is willing to stop and think about their position, you should reciprocate. You should also listen to them on how their consideration of their position has changed, and see if maybe that gives you insight into your position as well. Because you could both be wrong. Which is not to say that you should always jump straight to a compromise answer. Because sometimes the correct answer is not in between two people's positions. This is another thing that we sometimes see in politics, is we see someone set up a position that's very extreme, and then argue that, well, my position is much more reasonable than this extreme position that I invented that nobody was actually arguing. Therefore, my position is pretty much correct. You should be careful anytime somebody does that. Right? Because usually what that is, that's somebody trying to either divert attention away from a real topic by making up a topic that's much more extreme, or they are trying to convince you that their argument, because it's less extreme, is not also extreme, right? They may be trying to get you to move your position towards their position by making their position less obviously an outlier. And that's something that happens sometimes in negotiations as well. Is sometimes a negotiation will start out with an unrealistically large number. Right? I'll say, I want to sell my house. How much do I want to sell it for? $10 million. Right? Even if my house is not worth $10 million, right? I might say, you know, I'd like to sell my house for $10 million. And then move on to say something that sounds more reasonable, but is still quite high. I mean, it kind of depends on where you live. If you're looking for a 3-bedroom condo in downtown Manhattan, $1 million is quite reasonable. Right? I've definitely seen 2 and even 3 and 4 and $8 million condos that would be considered like a normal sized house out in the countryside, or even considered small, depending on where you live. Right? But let's say that I had one of these $1 million condos. I wish I don't, but let's say that I did. Right? I might say, well, I'd like to sell it for $10 million, but I know the market doesn't really support that. So let's say, 2 or 3 million, $2.5 million, right? Which is still way more than my $1 million condo is worth, right? Because I started out with 10 million, and I put the number 10 million in your head, and you said, no, that's just silly, right? And then I jumped down to 2.5, right? 2 seems much more reasonable than 10, but it's still double what it's actually worth. Right? So what I'm trying to do is I'm trying to get the bigger number into your head as being kind of reasonable. Right? So if you were thinking originally, like if you knew that it was worth about $1 million, you might say, okay, that's still too high. Right? But when you come back to the negotiating table, right, you might say 900,000 when originally, you might have gone with 700,000. Right? If I've dragged your position a little bit towards my end because I started out with something a little bit ridiculous, right? And then on the next round of negotiation, I'll propose something that's a little bit more reasonable. Right? I'd say, $1.5 million. And then my goal is to drag you above the $1 million that you know is the actual value. Right? If I can get you up to 1.1 or 1.2, right? And that's a win. And sometimes when you're negotiating for salary, you'll get companies that will do that too. Right? And they'll say, well, competitive rates for your job are, let's say that the work you do is actually worth, $65,000 a year, just as for instance. Each company might say, well, we could hire somebody to do your job for about $30,000 a year. Right, that makes it really hard for you to ask for, $70,000 to $75,000. Right, because they started off with a really low number. So, and you can't start at an appropriate number. If you started your negotiation at 65, right, then they're going to ask you to drop down to 50, 55. And you do always have the option, I guess, of starting out with saying, the lowest I'll go is 65. For reals, that's my lowest. And they'll come back and say, well, would you do it for 60? And you say, no, I was serious the first time when I said 65 was the lowest. But you'll probably get a lot of frowny faces for that, because people who like to play games at the negotiating table often have strong feelings about how those games should be played. And if you violate those norms, they'll be annoyed. There probably is. Excuse me, eating those watermelon chunks from the bottom of my. There probably is some sort of model that would more or less put people in the middle. For instance, you could have both sides, without showing each other, lay out their the range that they're willing to pay and or be paid. And say, this is the high section, this is the low section, and this is my happy compromise, where I'm not totally happy, but I would, if you pay me the minimum amount that I'm willing to accept, I would not be that happy about it. Right? But if you pay me the maximum amount, right, like if the sky is the limit, then of course I'm going to ask for all the money. And that would make you unhappy. Right? But that sort of system, it's hard to implement, because once everybody knows the rules, people start lying about what they would actually be happy with. They start trying to influence the outcome in their favor. They take a number that they would be okay with and say that that's the new minimum. Of course, when you start to do that, you always run the risk that if both sides are doing that, then there may be no intersection. There may be no mutually acceptable solution. And sometimes that happens for real. Sometimes one party will say, I think this work is worth $1 million, and the other party will say, I think it's only worth 500,000. No matter how much they negotiate, there's a point where that gap doesn't close anymore. At that point, you just have to accept that it's not going to work out. The person seeking a worker has to find somebody who will do it for less, and the person seeking work needs to find somebody who will pay more. And again, that's totally normal. That's how negotiation works. Now the catch is that when you're hiring direct employees, like people who are going to join your company and be part of your company and work there for a long time, their happiness and well-being has to be a factor in your consideration. If for no other reason than if they're not happy, then sooner or later they're going to leave. You're going to have to replace them. And you're going to have to teach whoever you have replaced them how to do whatever it was they were doing. Right. And there's also the fact that happier and healthier workers are more productive. If you treat your workers poorly, they do not do as good a job. It's not even necessarily it's not necessarily that they're being malicious either. It's that people who are stressed out are not as good at doing things. Right? So if you're not putting at least some consideration into the people who work for you, or who you work for, or who you work with, right, you're making their lives harder. And they're devoting some of the time and energy and attention that they could have put towards being productive, they're putting it towards dealing with the things that are making their life hard instead. Right? And like I was saying way back at the beginning, we only have so much energy and so much attention to give. It does recover over time. Right? You take some time off. you'll regain some of that energy, some of that attention. But if you have motorcycles going past, if you have a job that grinds you down to zero every single day, there's a chance that you're not going to recover to full just from, 1 or 2 days off. And if that's happening, then you're not going to be at full performance. Doesn't matter if you're trying to do a good job or not. Although, if we're being perfectly honest, at that point, most people are no longer trying to do a good job. They're just trying to survive. If you push your employees into survival mode, then amongst other problems, they will no longer take initiative on anything. They won't see a problem and fix it before it becomes an emergency. Because, especially if you don't reward initiative, right? People will wait until work becomes a real problem before addressing it. Especially if they have multiple things that they're trying to deal with. If you have 3 real problems on the table and something that's going to become a problem next week, you're going to ignore the thing that's going to become a problem in hopes that someone else will take care of it in the meantime, because you've already got your hands full. And generally speaking, when people are pushed into making decisions like that, they are no longer able to clearly judge the magnitude of the problem that's coming next week. So there's always a chance that the thing your employees didn't have time to pay attention to is going to be a much bigger problem than the things that were taking their attention right away. If everyone is focused on the $10,000 problem that's happening today, they might miss the $10 million problem that's coming next week. That's one of the things that was annoying me at work is somebody had a really expensive problem coming up. If we don't finish this by September, we're going to lose a lot of money. But they couldn't figure out who could fix the problem. So they kind of gave up for a couple of weeks. Until, right, now it's an emergency, right? Because now we need to get this done by September. And now that it's an emergency, everybody's panicking. I mean, not really. Because it eventually drifted over to my team. And my team did identify that this was going to become a big problem. Even though it was not our job to prevent it from being a problem. We went out of the way to find out not only what was wrong, but also who could fix it. And then got the people who needed the new system and the people who could fix the problem with the new system together and mediated between them to actually get it done. But the fact that it happened in the first place is annoying. And the fact that my team won't really get any credit is also kind of annoying, right? Because it took time and energy away from the work that we are responsible for in order to get these two groups together. when really honestly these two groups should have been able to manage this on their own without us, like a month ago. Not like back when there were, no, almost 2 months ago now. Yeah, back when there was 8 to 10 weeks to do the project and not 2 weeks to do the project. Right. So my team saved the company a lot of money, but it was at the expense of our projects. So we'll actually probably get in trouble rather than getting congratulated, because the managers are going to come and they're going to say, why aren't your projects done? And we're going to say, well, because we were busy mediating between these other two groups to save the company all this money. And then the managers are going to say, well, that's not your job. And what are we going to say? We're going to say, no, that was your job, right? If you can't say that to the manager that's that's in charge of your paycheck. Right? If we had let it sit, the company would have lost a ridiculous amount of money, many times my paycheck's worth of money. Right? You could give us 1% of the money that we saved, and we could split it between, there were, 3 or 4 of us that worked on this, even though it wasn't our job. And that would, you could replace our next year's raise, and I'd be totally okay with that, right? Be like, you don't get a raise because you spent time working on this other thing instead of on your project. And can I have a percentage of the money that the company saved? Because I would make that trade. That's how much money there was. Yeah. That's part of why things are stressful at work, is because the workers on my team are currently in negotiation with the managers, so that when things like this come up, right, either we need to get credit for working on them, or we need a way to pass it to the managers and have them get the other teams to do it, right? Because the end result of the company loses a gajillion dollars. That's not an acceptable result. Right? But right now, if we take the initiative to do something that's a little bit outside of our scope to save the company, right, we not only don't get credit for it, and sometimes we actually get punished for it. So it's not great. Right, and the part of me that is trying to be optimistic wants to make sure that it's not just that the managers don't understand how critical our intervention was, because without us, the people making the request would not have even found the people who could fulfill the request. Not in time, anyway. Now, hopefully, everybody involved has now learned how to escalate an emergency and how to do it properly, instead of depending on my team to do it for them. So that's what we did. We didn't do anything special. We just called all the people involved and said, here are all the current systems that are in trouble. Which one of you owns what, and what's the current status? And we got a list of the current status of all of the pieces. And we said, okay, the holdup is over here in this piece, and the person who's working on it can't fix it because they don't have permission. or they don't have the resources. Who has the permissions or the resources to fix this problem so that they can get back to work? And we just kept doing that until everybody involved was in the conversation. And then at that point, people who were stuck could go to the, they could go to the, it was in an online conversation where it was emails and chat rooms and Slack and whatever the kids are using these days to talk over the internets. Like, once everybody was involved in the conversation, whenever somebody got stuck, they could say, oh, hey, I'm stuck. Who can unstick this? And things moved along after that. Which is all totally stuff that the managers on the teams that were having problems could have done. They had somehow gotten themselves into a situation where they all thought they were waiting for somebody else to do something. So they were all waiting on each other. None of them were addressing the thing that was actually wrong. I assume it's because they were all busy, because they were all overworked, and it was like I was saying before, they didn't have enough attention to figure that today's small problem was going to become next month's, like, everybody gets fired problem, because we've lost more money than the entire department makes, so you're all fired because you screwed this up. That's a little bit of an exaggeration. It's not as much money as my entire product area makes. It was a big contract, though. Yeah. It would have been a catastrophe, though, except for that when it finally wound its way over and landed on my plate, I called the people that were starting to get worried that the project was not moving, and I asked them, why is this so important? Yeah, that was something that nobody had done, was send out an email and say, this project is important because a lot of money is on the line. Yeah, if you ever work in corporate America, you're going to find that that's the number one thing that gets attention. If you say, we need to fix this or we're going to lose this much money, right? That's a really easy way for managers to figure out which things are the most important. And they will always pick the thing that is worth the most money. Well, I hesitate to say always, always. Every once in a while, something more important will show up. That's just what I was saying earlier. Right? There's no, in ethics, even the ethics of managing a business, right? There's no absolute right and wrong. If you run a business that always picks whatever is most profitable, you're going to become a criminal very quickly. because paying taxes is not the most profitable. At least not if you think you can get away without paying them. Right? Labor laws are not always the most profitable. Again, if you think you can get away with it. Right? A good manager will balance long-term risk against the immediate profitability. Right? Like I was saying earlier, taking good care of your employees sets you up for success in the long run. Because when you take good care of your employees, they have more energy and more attention to spend, and they'll spend more of it taking initiative to stop problems before they become emergencies. Same thing with taxes, but from the other direction. Right? You want to make sure that you don't want to overpay taxes, right? So taxes are beneficial in the sense that they pay for collective goods and services that every individual and every company need. Right? If you live near a big city that has a metro system, right, some sort of subway or light rail or bus system, right? Those systems charge fares, yes, but those fares are not their primary source of income. They mostly make most of them at least, make most of their income from taxes. Right? So if all the companies in your city stopped paying their taxes, then the mass transit system would stop running and your employees would not be able to get to work. And what are you going to do then? You can't fire everybody, especially since it wasn't their fault anyways. But if nobody makes it to work, then you don't make any money. Now you're out of business. But the flip side is that if you pay more than your fair share of taxes, it gives your competitors an advantage. Right? Because if you pay too much in taxes, then money that you could have spent expanding your business, gaining new contracts, making new products, right? Now you're not doing that. Which is why most companies shoot for the minimum amount of taxes that they will not lose a lawsuit over. Right? Most companies are willing to, like at least the really big companies, are willing to have a lawsuit over their taxes because the money that it takes them to pay the lawyers is less than what the government wanted them to pay in taxes. Right, so that's a really cynical evaluation to make, I think. To say, the minimum in taxes plus the associated lawyers' fees versus the amount of taxes I would have to pay to not go to court. And then you pay whichever one is lower. Assuming you think you can win the lawsuit. Right? Every once in a while, you'll hear about a company that gets that one wrong, and they'll end up paying both penalty taxes and the lawyers. And sometimes that turns out to be worse than if they had just paid slightly higher taxes to begin with and avoided the lawsuit. Considerations like that are why I don't want to be a manager, ever. Right? I don't want to own a business. That sounds like a pain. It's also why I'm not super interested in running for government office, because that sounds super annoying. I don't mind ranting about it on the internet, though. That's never not fun. Debating whether I should take a break and come back and work on some more slides. Maybe just stop a little early tonight. And my typical stream time has kind of slid from, originally I was trying to start at 4:30, but I found that I often can't wrap up my day job and start streaming by 4:30, so I pushed it to 4:45. I do kind of want to get to the point where I work on this for about 3 hours a day, but just for a little while now, it's been a little too much. Because when my day job gets hectic, I need to pull time from somewhere to get, regular daily life stuff done. I know it's ridiculous, but for instance, I need to buy and cook food and then eat food and then wash the dishes and put the dishes away. It's crazy. My yard is kind of a mess. I do have a yard. It's small. I live near a big city, so yards are not something that too many people have big ones, because a big yard gets really expensive. A small yard is not too bad. Even if it's just a little strip of grass out in front. by the sidewalk. Technically speaking, I'm responsible for keeping it mowed. I need it. I need to do that. Also, I need it to not rain or be 100 Fahrenheit out. No, I take that back. I need it to not rain and to not be 100 Fahrenheit. I need both of those things. It needs to be dry and not life-threateningly hot. That's half the reason my yard is a mess. Is for the whole past month, it's been ridiculously hot out. I got part of it last week, but I need to get the rest of it. Yeah, that's the other thing. When it's hot out like that, I can go outside, but only for a little bit. I'm an internet dweller through and through. I'm averse to touching grass, even if I'm touching it with the lawnmower or the weed whacker, depending. I was trying to edge the sidewalks. Apparently people like it when your sidewalks are nice and neat. Nobody's gotten on the case about it, really. But I've drifted to the point where I'm the scraggliest lawn in the neighborhood. I want to at least be second from the bottom. I don't want to be at the very bottom. I personally don't think lawn care is that important. Like, it doesn't actually change anything if your grass is like super nice and neat like a golf course. But people will say, "Oh, that's ugly. It's reducing property values. We're gonna call the government." I don't live in an HOA. I've never lived in an HOA. Because people who live in an HOA jump on stuff like that right away. Right. I can tell my neighbors probably are not super happy with it. And it's good to keep your neighbors happy. It's kind of like keeping your workers happy. If you keep your neighbors happy, then when they notice a problem, they'll say something before it becomes an emergency. It always astonishes me how many times people overlook the value of maintaining good relationships with people that you encounter. Like, especially people that you encounter often, or people who are about to make you food. That one always confuses me, is why, if somebody's about to make food for you, like at a restaurant, why would you treat them badly? That seems like all risk and no gain. That just seems like a really bad idea. But I mean, it goes for your coworkers and your neighbors too, right? They're people who someday will be in a position to help you or not. And going out of your way to maintain good relations makes it more likely that they'll choose help as opposed to not. Yeah, maybe I'll try that before the sun goes down. It was hot out earlier. Maybe it's cooled down enough that I can at least trim the sidewalks a little bit. I don't know. It's still unpleasantly warm. Maybe I'll give it a try anyway. If I can get part of it done, then at least it'll show that I'm making an effort, and I'll have less to do when I try to do the rest of it on the weekend. Here's to me trying to learn how to use a weed whacker like a real adult, like an outside adult and not an internet adult. Crazy. But I'm gonna get to that.